Welcome back, students. In this video, we will see a few problems on trigonometric identities. So presently, we have covered so far the theory part of all these trigonometric identities, and presently we are going to be seeing some sample and board problems on trigonometric identities. In order to understand this video better, kindly read and check my earlier three videos, part 9, 10, and 11, where I have dealt in depth about these three trigonometric identities. The thorough understanding is required for you to solve these problems easily. So please check those videos. So we are going to use mainly these three identities to solve the problem. Okay. The first problem, the value of 1 minus cos A into 1 plus cos A into cosec square A is, excuse me, there are four options here. So first thing you have to notice is this is pattern 1, that is the trigonometric identity 1. Sine square plus cos square. If you see the earlier video 9, we have very clearly dissected or shown that one of the form of this equation, sine square theta plus cos square theta, is equal to 1 plus cos theta into 1 minus cos theta, which is from identity 1. So all you need to do is, from the trigonometric identity 1, you would say that sine square A plus cos square A is equal to 1. Hence, 1 minus cos square A is equal to sine square A. This 1 minus cos square A, you are going to substitute. See, you are going to multiply this both. 1 minus cos A into 1 plus cos A is 1 minus cos square A. And from the identity 1, you know 1 minus cos square A is equal to sine square A. So you are going to substitute that sine square A here into cosec square A. Sine, sine square into cosec square is nothing but this is inverse. Cosec is equal to 1 by sine. So sine square by sine square is equal to 1. So going to the next problem, 9 secant square theta minus 9 tan square theta is equal to, you have four options, 1 minus 1 9 minus 9. So seeing this, you should be able to, whenever you see a secant square and tan square, or cot square and cosec square, or sine square and cos square, immediately you should be able to relate it with the respective trigonometric identity. In this case, it is trigonometric identity 2. So we saw in our video 10 that this can take multiple forms. One of the forms is tan square theta plus 1 is equal to 6 square theta. The tan square goes to the other side. So 6 square minus tan square is equal to 1. Okay. So we are going to use this to solve the problem. So, excuse me. So the solution is 9 6 square minus 9 tan square is equal to, you are going to take out the 9 in common and put 6 square theta minus tan square theta. And you are going to mention that from trigonometric identity 2, we know that, or you know that 6 square theta minus tan square theta is equal to 1. So you're substituting this value of 1 over here and get the answer as 9. So the option is C is the correct answer. So this is problem 3. This kind of problem has been quite repeating. This is a quite repeated pattern. So let us see. So they have given you secant theta minus tan theta is equal to 1 by 3, and they are asking you the value of secant theta plus tan theta. So in video 10, we saw one of the forms of this equation, second identity 2, is secant square minus tan square is equal to 1, which uh, it gets divided by using the a square minus b square formula as a plus b into a minus b, which is nothing but secant theta plus tan theta into secant theta minus tan theta. Okay, so this is what we are going to use. This is a quite repeated problem. So even the recent 2026 sample paper, whatever CBSE has released, we can see that problem pattern here. Problem number 5, the same pattern they have asked. Very simple, very simple. So the answer is 1 by x. We will see how to write it. So we are going to mention as a solution identity 2, tan square theta plus 1 is equal to secant square theta. Okay. When you are rearranging, it becomes secant square minus tan square is equal to 1. Secant square plus tan. This you are going to divide it as secant square plus tan into sec theta plus tan into sec theta minus tan is equal to 1. You know the value of sec theta minus tan theta is equal to 1 by 3. So you are going to substitute that value. So secant theta into tan theta into 1 by 3 is equal to 1. So you get the value of secant theta plus tan theta as 3. It's going to be an inverse relationship. So if it is 3, it is if it is 1 by 3 here, it's going to be 3. If it is x here, it is going to be 1 by x, like in the sample problem. So they share an inverse relationship. These are very easy to solve. So then going to the next fourth model, secant square theta minus secant power 4 theta minus secant square theta is equal to 4 options are there. Note that all 4 options are in tan. So identity 2 is the one which relates secant and tan in its equation. That is 1 plus tan square theta is equal to secant square theta. So somehow you have to relate this to one of these here. So what I'm going to do is I'm going to take the secant square outside. So secant square outside I'm taking and multiplying secant square theta minus 1. And each of this I'm going to represent as tan form of the identity 2. For example, secant square theta is equal to 1 plus tan square theta. And similarly, secant square theta minus 1 is equal to tan square theta. So I'm going to just put it in their respective tan forms. After putting, I'm going to multiply this tan square with this and with this, and the answer is tan power 4 theta plus tan square theta, which is nothing but option C. So from the next video, we will see little bit complex problems around this trigonometric identities. Bye till then. Thank you.